Music theory with OneNote, distance, absolute color system leading into concepts of modal range, modal distance, and intervals. If you don't know some of those concepts, that's okay because we're going to strip it down to its bare bones, looking at all local possible distances, not including octaves, of which there are only 12, assigning a color to each of those distances so that you can actually name the distance with a particular color. So get ready and some coffee, because although we're just playing with one note, it's a beautiful note. You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS, presentation 2139, OneNote Distance, Absolute Color System, list of presentations on the right, which we plan on adding plenty more to shortly. Also noting in this OneNote presentation, we'll spend all our time on music theory, but we have another similarly numbered and named presentation where we build these tables in Excel, practicing Excel, music, and table visualization skills all at the same time. Let's go on down to our fretboard to get a reminder of our overall objective, which is to optimize the use of color to better understand music theory in general, and more specifically, better navigate the fretboard. This being an example of a fretboard with a low or heavy E string, the one closest to the ceiling. On top, we are looking at the collection of notes, the 7-note collection around the C major, and there's two ways that we will typically be applying our color system from a practical standpoint to analyze the fretboard. One is to use a color system tied to the notes so that we have 12 notes and each note has a standard color, allowing us to actually label the notes not just by number, not just by letter, but by color. So I can say that if I'm going from the A to the C, or if I'm going from note 1 to note 4, I could also say I'm going from the red note to the yellow-green note. And that's just another way to kind of visualize it, which again kind of triggers another area in our brain, this visual or color optim area, which as an accountant, I can tell you helps on a spreadsheet. You know, I've been in a world where we didn't do that, and I've practiced with that. So it's not, again, there's no kind of weird symbology going on with the crazy colors. I know we have crazy colors all the time. You think there's some political stuff. No, it's still useful. Even if you were pulling out the crazy stuff, no gaslighting here. It's just useful to have the colors. So we've mapped out then the color wheel on the pitch wheel and made them as spread out as possible along the color wheel, so that this gives us the maximum distance between the 12 notes that we can do. Now, the other way we might use color is to utilize the key of the Ionian C, which is standard in Western music, to use it as our key. It's not special in any mathematical way, but it's usually the one that we use as our center point, tie the colors to it, similar to the Nashville number system, then numbering it. You can see the Nashville number system has the Ionian is the 1, the Lydian is the 4, and so on and so forth. We can also tie the colors to that as well, making these modal points the absolute system. So in other words, if I was going to move from the collection of notes around the key of C to the collection of notes around the D major, you can see now the D is the Ionian, but if I keep it so that we have absolute notes, the A is still the red note in this system. That could be useful because then you can imagine the color wheel all rotating. And if you can really visualize the color wheel, you can use an absolute color system and then be able to think about the relationships on the color wheel a little bit more systematically than you might be able to do imagining the note wheel. But I think it's a lot easier oftentimes for many people to say, hey, look, I'm going to start on this one with the 7-note collections around the key of C, and then when I go to the key of D, I'm not going to tie the color to the note, but to the node. So now we have this yellow-green on this node. So now I could see this shape, which I would call position number 1. You might call a G shape from a cage system, a G-shaped C major chord. And now it's up here. So the red is not on the A, the red is on the B now. and it's tying into this shape. See if I can get these both in there at the same time. So it's tying into this shape. Those are the two main ways to see it. But now what we would like to do is add distance. So if I'm going, let's go back up to the top one here. If I'm going from this A, let's go from a C. If I'm going from this C to this E, how many notes away? 1, 2, 3, 4 notes away. What's the distance in terms of the 7-note collection? It's 1, 2, what I would call modal half steps up, which means it would be the third scale degree if I make this the 1. So I would like to know a color set for the distance. Now I could use the destination point. I could say I'm just going to keep the destination, and that will give me the distance from any particular point will be the destination. But similar to having a permanent color set for the notes, I'd like to have a permanent color set for all of the distances. So when I talk about local distances, you can only have 12 of them if we're not talking about octaves. So we have another list of 12 that we would like to map colors onto. Now, just note that there's one way that you might think about doing this is to take the average, meaning if this is yellow-green and that's like sky blue, I believe that is, then I could take the average of those two. In other words, I could measure this A is 440 hertz and this C is whatever the C is, I forget. But you could take the average distance in hertz, convert that to the color wheel, possibly taking the log average, and then get the average color, which is a really cool concept. I actually mapped it out, and that would be a great way to kind of visually see how the colors can blend together. The problem with that, however, is that you still end up with one color. So it doesn't really help us from a visual standpoint on the fretboard. What would help us is to have a whole set of colors assigned to the distances. So in other words, the color set we have now is assigned to either the note or the node. This is either assigned to the Aeolian node or modal point, or it's assigned to the A note. So what I'd also like is to have a color system assigned to the distance going from like this A to this C. That would be a distance of 1, 2, 3. I would like to have an absolute color system standing for a 3-note distance. Okay, so the way I can do that is I could use the same colors because these colors are maximally spaced on the color wheel, but then I'm going to have the same set of names for colors that will be naming the distance as well as the points. So even if the colors are similar, in other words, I'd like to have a whole different naming convention of colors that I can name the distances from. I think that's the most practical thing to do. And so how could we do that? We could shift the color wheel a little bit so that you could still end up with 12 colors that are distinct. So what I'd like to be able to do is to say, if I'm going from this C to this E, I could say it all by color. It's going from yellow green to, I think that's sky blue, and then the distance is going to be like mint blaze, I think is the color. We have to get a little creative with the color, but it's mint is going to be the color. So I can name the whole thing by color, basically, is going to be the idea, which sounds like it's not practical, but I think the more you look at it, it's actually a practical thing to do. It can help you to kind of visualize what's going on. Let's recap what we have thus far. We've got notes 1 through 12. We've measured them in hertz, and then we kind of map them onto a circle so that we could see that these notes, these 12 notes, are evenly mapped around a circle. So these are the degrees of the circle, which are going to be our kind of equivalent to the hertz that we're working in, remembering that we're building our normal range in the middle, which is different. If you were to try to build a system like in software, like a MIDI or something like that, then you might, from a computer standpoint, note, start at 0 hertz and then count up from there, which isn't what we would do practically from a music standpoint because no one plays in 0 hertz. You can't hear anything. The wavelengths are too short. But mathematically, it doesn't matter if you're using a computer to have the numbers come up from there. But what we want to do, of course, is start in the area that we're likely to play in, that sounds good to our ear, which is on the piano, around that middle point of the piano, which is around middle C. But note, the piano throws us all off because it should start at A, because that's the range of alphabet that we worked in, 440 hertz up to whatever it is for a G sharp. So that's the range we want to work in, which is the middle part of the piano. So that means we're kind of working, you can visualize it as like a number line. We're in the middle of the piano, and we're going to the right, which is going to go higher in pitch. We're going to the left. So when I think about our normal 360-degree circle, we're thinking about it in the middle range, which would be around C4, although, again, I'm going from A to G, middle range, and I would like to call it the middle, or 0, if we could change the convention, but, it is what it is. And then we can also visualize it as we're going up an octave, or we can just keep on visualizing it as a circle. So remember, in our fretboard down here, we've got all of the colors. Even though we're going up an octave, we're using the same colors. We could add another factor down here to change the color, meaning this is a different color set. Don't worry about the colors, but the point is the color's getting lighter if you go up an octave. That's using a factor different than hue, which is the lightness factor. We'll talk about that more later, but right now we're just thinking about that middle point of the range. So that gives us only 12 colors that we need to map onto it. So we're just going to convert the color wheel, the 360-degree color wheel, into these degrees, which are equivalent to the pitch wheel. So let's do a quick recap of that, and then what we're going to do is rotate the color wheel 15 degrees. So all of these, you can imagine these going around the circle, 0 degrees, 30 degrees, 60 degrees. How could I get another set of colors, which end up with 12 colors, to measure all of the distances, which are as far apart as these as possible and as far spaced between themselves as possible? Well, we can just rotate the color wheel. Again, that's not as satisfying mathematically, because like I'd say, I would like to be able to say, and I did do this, and it might be a fun exercise to do, to say like, if I was going from A to C, I could take 380 plus 452 divided by 2, or I could take the log average, and that would give me an average hertz, which I can then find the relative point on the degrees color wheel, and then I can get the log average color, which would be cool. But again, it doesn't really give me much more information. What I want to do is come up with 12 colors as distinct as this as possible with different names, so that I can see everything by color pattern, both in terms of points, notes or modal points, and in terms of distance, meaning how far did we go standpoint. So I'm just going to rotate the color wheel. That's actually the most me and ChatGTP talked about it, my best friend. We discussed it, and that's what we're pretty, and Chat's smart. Chat is super smart, and that's what Chat thinks too. It's not just me. I've got really smart friends, or one at least. So that means what we want to do is memorize these color sets and then tie them to the note. So this A, let's just do a quick recap. The A is note number 1. It's an A. It's red. I could just call it red. I don't need to say it's an A. I could just say it's the red note. It's the red note. 2 is A sharp or B flat. It's orange red. The 3 is a B. It's yellow. The 4 is a C. It's yellow green. The 5 is a C sharp or D flat. It's just green. Notice that the colors are actually better than our note naming convention, which chose to use sharps and flats. I don't care how many people try to convince you that that's somehow magical and it's a better system. It's not, right? We should only have one name. Okay, I'm sorry. There's cool things that happen from that, but it's actually more logical to call it just green or a 5 than C sharp or D flat, right? So I'm just going to keep pointing that out. Again, I know that upsets people sometimes, but it's just, the 6 is a D. We're going to call that spring green. The 7 is a D sharp or E flat. I'm going to call that cayenne. The 8 is an E. We're going to have sky blue. The 9 is an F, which is just going to be blue. The 10 is F sharp or G flat, which is violet. The 11 is a G, which is magenta. And the 12 is a G sharp or A flat, which is rose. Now, if we wanted to go up another octave, we could either use the same color convention so that all A's are red, all B's are going to be the same orange-red, or we can use another factor, not hue, not the color, but the brightness. So that brightness, now I've changed it a little bit from the prior presentation because I think these are better spaced colors for distance. So in other words, if we go up if I go down an octave, we're going from a brightness level of a 0.5 to a 0.3. Again, you could just ask ChatGTP because the chat's really smart. They'll work with you. I gave him a good reference for you, so he'll work with you. So just ask him and be like, he's my TA. We're gonna take these hues. Hey chat, I'd like you to change that to have give me the hex numbers that aren't 0.5 but they're 0.3, and give me an Excel worksheet that gives me all of the numbers and format the cell with those numbers. So now we have the same red, it's still red, but we have a lightness of a 0.3, allowing us to say this is the red note an octave down. An octave down from where? An octave down from the middle range, which on the piano is around the middle C, but I'm thinking of it going from A over, meaning I didn't start the color spectrum on C, we started this color spectrum on A, because again, that would be the more logical thing to do if the piano hadn't skewed us in our kind of thinking. So the color, so then the orange, if we go an octave down, will be at 0.3. So 0.3, if we go an octave down, would be here. We've got the 3, which is a B, is going to be yellow. So this would be 0.3 an octave down, 0.7 an octave up. What if we go 2 octaves down? Then the lightness factor will be 0.2. What if we go 2 octaves up? We have a lightness factor of 0.9. So that gives us the middle range on the piano, which I would like to label A through G sharp as 0 in terms of octaves, and then go up 2 octaves to the right in pitch, down 2 octaves lower in pitch. You get something nice and symmetrical, but it's currently called C4, started on C and whatnot, so we have to deal with that. Okay, so now what I'd like to do is say, okay, what about distance in terms of distances, which is going to lead into our idea of traditionally called intervals, which I would like to more systematically call modal ranges, and we'll talk more about that later. But let's explain just from the bare bones what it is. We can compare it to a ruler. Now, I know if you're not in the United States, you might not use a ruler. It's like, why do you use rulers? Because King George's foot or King Henry or someone's foot was the ruler, and we like the ruler, but you don't like King. I know, but we like the ruler. So it has 12 inches in it. So, right, it's got 12 inches. So that means that if I wanted to measure every distance in the base unit of inches for a ruler, then I could either, I could start at 0. I could take 1 step forward. I could take 2 steps forward, 3 steps forward, and so on and so forth. So it's a little wonky because because you're measuring from that first point. But you only have 11 distances plus the one you're on where you didn't go anywhere, which is 12 distances. So that means in the local range, in the middle octave, there's only 11 distances. And if I go an octave up, we have the same phenomenon that we can basically count it as though it's the same number, right? We have the exact same thing is happening, except in this term, we can't use the exact same colors. We could, but we have something different happening because this is measuring a distance. The color set we had before was measuring a point. So we'd like to have a whole new color set. How could we do that? Well, I can take the colors that we had at 0, 30, 60, 90 and just add 15 to them. So now that we're at 15 degrees, 45 degrees, 75 degrees, and so on and so forth. So this is as maximally distant from this as possible, right? It's as maximally distant from this as possible, and it's still as spread out on the color wheel as possible. Let's look at it down here. Notes, we start on note 1, which is an A, which is where we started the spectrum. The start of the spectrum is on red, therefore A is red. When we look at the shortest distance, that's where we're going to start the spectrum from a distance standpoint. The shortest distance we can travel is nowhere. In other words, if I'm on the A note, that's the point, and I don't move anywhere, I went a distance of 0. So we could have labeled this as red, starting the spectrum there. But the problem is then you've got red naming both the point as well as the distance. In other words, if I named this all with color, it would be I went from the red note to the red note, which had a distance of red, right? So as long as you kind of differentiate and say, look, the red here is assigned to the distance and not to the point, it could work. But I think it's better to have a unique name for distance. Therefore, I don't even need to say distance. I can say I went from red to red, orange flame, right, is the distance, right? Red, orange flame to red means I went from red, distance of 0 to red, okay? So that means this orange flame didn't start on the 0 degrees. It started on 15 degrees, which means you can still kind of visualize the color spectrum to see where this is going to land, but it's just tilted. So these are going to be shifted up 15 degrees. So in other words, if I go to a note number 2, we said that was an A sharp or a B flat, which is going to be orange red. What's the second distance that we can have, the second shortest distance? It's a half step. So I went a half step up, which you might also call a 1 note away minor second. I would like to call it a 1 note away. It would be a 1 note away first modal half step, right? Which would be a minor second. But again, we'll get to that later. But it's going to be called amber gold, which I think you could pick one or the other, amber or gold, but we'll go with the amber gold. So in this case, we can say if I traveled from A to A sharp, that would be 1 half step. I went 1 step up. Then I can name that I went from red to orange red with a distance of amber gold, right? And then the next one is a 3. Note 3 is yellow. So yellow is the next space on the color wheel, red, orange, and then yellow. So the next distance that we can have is a distance of 2 half steps, which would be 1 whole step, which would be a 2 note away major second, which I would like to call a 2 note away first modal half step, because I think which would be the second or major second scale degree. We'll talk more about the names and why those are kind of messy later, but it's actually better or easier to name it with color. I went from red up to, which would land me on the yellow, having a distance of chartreuse or chartreuse yellow. So notice that the chartreuse distance could be like if I started on B and I went up 2 notes, I'm still going to use chartreuse yellow, meaning the chartreuse yellow isn't like an average. It's not a log average. It has no meaning that's corollary to distance, like would be cool if we took the log average, but it's just an absolute distance. That way, no matter where we start from, we're just going to use the same color system for the distances. All the distance color systems will be the same then, similar to when we use the C major key to help us to then give a permanent Nashville number system modal color system. All right, so let's say we go to the 4th note. That would be a C, which is a yellow-green, which makes sense on the spectrum, red, orange, yellow, yellow-green. Then if we start over here, we went 0 distance, 1 distance, 2 distance. Now we're going to go 3 notes up, which you can imagine going from A, 1, 2, 3 notes up. That would be normally called a minor third. I would like to call it a 3 note away second modal half step, which would be a minor third. But we couldn't label it with color. I went from red to yellow-green with a distance of lime or lime spike. And again, I know these names over here are a little bit longer. They look like someone who has lime spike hair, like made the color or something. So, but that's good, I think, because that lets us know that the average colors over here, or the ones that are more plain, are going to be the note names, and then the more like colorful color names are going to be over here for the distance names, which again might help us to distinguish between the two of them. The next one is going to be note 5, which is a C sharp or D flat. We say that's going to be just flat green. And the distance, the next distance is 4. So we can go a distance of 0, 1, 2, 3, or 4 half steps. And we can often call 4 half steps a 4-note away, a 4-note away major third. I would like to call it a 4-note away second modal half step, which would be then a major third. And we'll talk about that later. But we could say that if I started on A and went 1, 2, 3, 4 up, I went from red to green. So that's going to be like, and the distance is a mint or mint blaze. Could just call it just mint, I think might be the easier way to go. And then the next one is going to be 6. So now we have note number 6, which is a D. That's going to be spring green. We're going to say that we have a 5-note distance is the next distance. Remember that this 5-note distance has nothing to do with this D. It just so happens that if I start on this A, I'm going to get 1, 2, 3, 4, 5 distance. But if I started on the B and I went up 5, I'm still going to use aqua mint. This aqua mint has nothing to do with these colors except that they're going to be 15 degrees different than the degrees of the color wheel over here. That's it, right? Other than that, they're going to be somewhat arbitrary because all the distance are the same. It doesn't matter where the start or end point is. Okay, so a 5-note distance is we typically call that a perfect fourth. I'd like to call it it's going to be a 5-note away third modal half step, which would be a perfect fourth scale degree. But we could say it's going, if I start on an A, I would be going from the red note to the spring green note, which has a distance of aqua mint. Again, you could possibly call it just aqua or mint, but we have aqua mint. All right. So then we have 7. 7 is a D sharp or an E flat, which we called cayenne. If we have the distance, then we had 6 half steps away. So 6 half steps away, then we're gonna say that's gonna be electric sky. 6 half steps away is the midpoint. So we have the midpoint, which is usually called it's either an augmented fourth or a diminished fifth. And so we could say that we're going from red to cayenne with a distance of electric sky. Okay. And then note number 8 is an E. We call that blue sky. And so the distance of 7, so this is a distance of 7. It doesn't have anything to do with this E. It just happens to be similar on the wheels from the starting point, right? Because we started on the same, it's close 15 degrees off. So this has a 7-note distance, which is usually a 7-note away perfect fifth. I'd like to call it a 7-note away fourth modal half step, which would be a perfect fifth scale degree. Scale degrees are all off by 1 in the way I see it. But that would be deep azure. So we're going to say that that's going to be, we could say we're going from red to sky blue, which has a distance of deep azure. Hopefully I'm saying that right. The next one, note number 9, is an F, which we just called blue. And that's a nice normal name. I know that one. And so then we're going to say the distance is 8. So 8 notes away is usually going to be a minor 6. I'd like to call it an 8-note away fifth modal half step, which would be a minor 6th scale degree. But we're going to call that ultraviolet grape. Ultraviolet grape. So if I went from the A up 8, 1, 2, 3, 4, 5, 6, 7, 8, we're going from red to blue, which has a distance of ultraviolet grape, which is a distance of 8 half steps. The next one is 10, note 10, which is an F sharp or G flat, which is violet, so purple or violet. And if we go 9 steps up, that's the next distance that we're going to be taking a look at. We call that orchid fire. I keep on wanting to say orchard, but orchid fire. We're going to keep it orchid. We're going to call it. So that's going to be then 9, which is normally going to be a major 6. I'd like to call it a 9-note away 5th modal half step, which would be a major 6th scale degree. We'll talk more about that later. But I could say we're going from note red to note violet, which has a distance of orchid fire, which is a distance of 9 half steps. A G is note 11. We call that magenta. And if I go a distance of 10, then we call that fuchsia amber. So fuchsia, I think we had amber some here before. So maybe we can just call it fuchsia. So pink. Can't one of these be called just pink? Anyways, so we're going to say, so that's going to be a distance of 10, which would be a minor 7. So I'd like to call it a 10 note away 6th modal half step, which would be a minor 7 scale degree. But we could say we're going from note red to note magenta, which has a distance of fuchsia or fuchsia amber. And then finally, we've got note 12, which is G sharp or A flat. We have that as a rose color. If we go a distance of 11, the furthest we can go without wrapping around the circle again, that we're going to call that crimson punch. So that 11 is usually a major 7. I would like to call it an 11 note away 6th modal half step, which would be a major 7th scale degree. And I could say if I went from the red, from A to G sharp, I could say I'm going from red to rose with a distance of crimson punch. Okay, so if I go back up top again, we now have all of the hexes for the middle distances. So the way I did this, if you want to recreate it yourself, you can try to get access to our worksheets. We'll show you these, but you can just ask ChatGPT, give me the HLS distances for these distances and convert them to hex distances and give it to me in an Excel worksheet with both the numbers as well as the actual formatting, and make sure it has a lightness factor of 0.5, which gives you the most pop on the lightness factor, which isn't color. Lightness is like how bright, it's similar to brightness. Okay. Now you could say, well, what if I go a distance above 12? Well, we've left the middle range on the piano. And remember, I'm thinking of the middle range going from A to G sharp, not C. Middle range is going from A. That's where we started. So what if I go from A and then I repeat the A again? Well, now we've gone up another octave. So instead of going from A to A, which would be a distance of 0, which would be orange flame, I've gone from A to the octave up. Well, I could keep that as the local distance as though I'm going around a circle, still calling it orange flame. Or I can say that we went up an octave, giving up this color, which is still orange flame, but it's going to be a hue lighter, or lighter, right? 1 degree lighter, right? So we can then label the differences between that distance. If you didn't go anywhere, if you went from A to A, then you're going to have a distance of orange flame. If you went from A to an octave up A, 12 note distance, it's still orange flame, but a light, 1 factor lighter. If you went from A to B, that would be a half step, which we would call amber gold. But if you went the half step plus 12, an octave up, then we're going to say it's an amber gold, but it's going to be a shade lighter because you went an octave higher than that, right? Similarly, Charlotte, you went 3 steps. Locally, it would be chartreuse. But if you want to be more specific, because you went an octave higher, chartreuse with a lighter factor, 1 factor lighter factor. I have to come up with a better name for that. If you go 2 factors lighter, so now you go, instead of going from A to A, you didn't go anywhere. Instead of going from A to the next A, which would be 12 frets, 12 notes up, you went 24 notes up. Well, then it's still going to be orange flame, same color. You went orange flame, but 2 octaves lighter. 2 octaves lighter in terms of the color pitch. So then you could also go down the other way. What if I went I went down? So now I'm saying instead of going a distance of 0 to 0, I didn't go anywhere, the orange flame. I went from where I am down an octave. So that means you're going to go in the octave on the other direction. It's still going to be orange flame. You went from A to A, but you went an octave down, which is going to be 12, which is going to be it's going to be orange flame, but an octave darker. And then if you went the next one up in the local distance, if you went from A to A sharp, you went a half step, it would be amber gold. But what if you went from A to A sharp left, right? You went down minus 12. Well, you'd still went a local distance of amber gold, which would be a half step, but you went an amber gold, an octave shade lower, an octave lighter, lower in lightness. And then you could go 2 octaves lower. So if you were on A to A, local distance would be orange flame. You didn't go anywhere. But now you're going from the A to an A that's 2 octaves lower. You went 24 half steps in the negative direction. We're still going to call that orange flame because that's the local distance, but it's going to be 2 lightness factors lower, 2 lightness lower, 2 lightness lower, 2 lightness higher, right? So that's going to be the general idea. So it mirrors beautifully with this system, but these are the points. So in this case, we have the local distances with more of the plain colors starting at 0 and going up 30 degrees around the circle. And then as we go an octave higher, we have a lightness factor, 1 lightness factor higher, 2 lightness factors higher, and then an octave lower, 1 lightness factor lower, 2 lightness factors lower. Same thing is happening over here, but we are now measuring distance. Therefore, all of the colors are going to be 15 degrees higher as the starting point or from the starting point, but we're going to be using an absolute color system for distance, meaning it doesn't matter where the starting point is, only matters what the distance is. The distance is always going to be the same. A major third distance will be the same if it's a major third distance from the A or from the G. If you're measuring the distance, we're going to use a standard color set for that major third, which would be 4 notes away, mint or mint blaze. But you get the same phenomenon that you have the local distances, and then you could go a distance plus an octave, 12 up, which would be, again, a lightness higher, 2 lightness higher, or lightness lower, 2 lightness lower. All right, that's the general idea. And again, I know this, like you might think that this is not, I really think that this is practical, because once we map this on the fretboard, you can start to visualize the fretboard from top to bottom, low or heavy string on top, and start to look at which we'll do later. We'll format it not to the points, but rather to the distance. And then you can practice the distance names associating it with the color, practicing both the current interval names as well as possibly the more logical interval names based on modal distance, right? Which actually makes more sense